We have a question here. This is a question given to us by one of our fans in our comment section. And we have said that there are two methods that can be used to solve the question. One is the approximation technique. A video on the approximation technique has been posted. Try and locate that video and watch it to see how the approximation technique can be used to solve this equation. In this video, we are going to be using the graphical method to solve this equation. Here we have the question. If we rearrange this question, we have that 2 raised to the power of x equal to 5. When x crosses this way, we have minus x. So here we are going to draw a graph of y equals to 2 raised to the power x function 1 and the graph of y equal to 5 minus x, the second function. After plotting the graph of these two functions, where the graph intersect, from there we are going to take our value. Now, let the value of x range from, let's say, -2 to +2. You might want to ask, why -2 to +2? It is not compulsory it must be -2 to +2. You can choose any range of value. You can choose from +5 to -5, from -10 to +10, but we feel that from -2 to +2, we have about 5 digits, which is enough for us to plot the graph. Hence, we are going with -2 to +2. So for each of these values of x, we are going to find the corresponding value of y using this function and then this function. So let us draw a table of value for this graph. We have our table of value. Here we have the value of s ranging from -2 down to +2. Here we are going to look for the value of y for each value of x, y 2 raised to the power x, and then y 5 minus x. When x is -2, y, which is 2 raised to the power x, let us quickly calculate it. 2 raised to the power x will be equal to 2 raised to the power of -2, and this gives us 1 over 2 raised to the power 2 is 4, and you can convert this to 0.25, so that when x is -2, y is 0.25. Similarly, when x is -2, y here, 5 minus x, let's quickly solve it. 5 minus x equal to 5 minus, in bracket, minus 2. Minus multiply minus is plus, so that we have 5 plus 2, which will give us 7. So when x is -2, y in this function is 7. If you apply this process here and here, you find out that when x is -1, y here is 0.5. When x is 0, y here is 1. When x is 1, y here is 2. And when x is 2 here, y here is 4. Now coming here, when x is -1, y here is 6. When x is 0, we have 5 for y. When x is 1, we have 4. When x is 2, y is 3. Simply apply the method as it is explained here and you get these digits for y. Apply the same method here, you get all these digits. So we've got a table of value for x and for the y's. Now we're going to plot a graph of y equals to 2 raised to the power x and y equals to 5 minus x. So let's go. Here is our graph. We have the y-axis and here we have the x-axis. On the x-axis, we have that 2 centimeter represents 1 unit, while on the y-axis, 1 centimeter represents 1 unit. We have a greater number of digits on the y-axis, hence we are using 1 centimeter to 1 unit, while on the x-axis we have fewer digits, hence we use 2 centimeter to 1 unit. So let us start by plotting the graph of y equals to 2 raised to the power x first. Now when x is -2, y is 0.25. Here is 0 from when x is -2. Here is 0, here to here is 1. The middle is 0.5. So in between the midway and this 0, we have 0.25. So I'm going to trace from 0.25 down to this point where it corresponds to -2. Here's our point corresponding to this 0.25 on y-axis and -2 on s-axis. When s is -1, y is 0.5. Here we have the midway is 0.5. So we trace it down here and put our point somewhere there. So we have our point there corresponding to these two values of y and then x. Next, when x is 0, y is 1. X 0 and y is 1. We put our point there. Next, when x is 1, y is 2. When x is 1, y is 2. We trace it down here and put our point somewhere there. We have our point there that correspond to 2 on y-axis and 1 on x-axis. And finally, when x is 2, y is 4. So we have x as 2, y as 4. We're going to put our point somewhere there. So we have the point here that correspond to 4 on the y-axis and then 2 on the x-axis. Now we are going to connect all these points together to get our y equals to 2 raised to the power x function. So here we have y equal to 2 raised to the power of x function. Next, we are going to plot the graph of y equals to 5 minus x. And we have that when x is negative 2, y is 7. We have the 7 point here, trace it to this point, and we have our dot there that correspond to 7 and negative 2. When x is negative 1, y is 6. Look at the point 6 here. We have our dot here that correspond to 6 and negative 1. When x is 0, y is 5. X is 0, we put our point here, y is 5. Next, when x is 1, y is 4. When x is 1, y is 4, and we have our dot at this junction. And finally, when x is 2, y is 3. So we have y as 3 traced to the place of 2. I'll put our point here. Now we are going to connect all the dots together. And this gives us the function of y equals to 5 minus x. Now let's locate the point of intersection of this graph, which is here. We are going to trace this place down to the x-axis where we take our reading. So we've traced it down here to the x-axis. We are going to read this value on the x-axis. We have that here is 1. Here is 1, the midpoint is 0.5, so that from origin to this point is 1.5 plus from this 1.5 to this midpoint here is 0.25, so that the mark here can be judged to be 0.2 or maybe 0.22. So we have 1.5 plus 0.2, it could be 0.2 and some fraction. Add it together, you have 1.7 and some fraction, let's just say 2 or 1 as the case may be. So from this graph, as we have seen, we can comfortably say that the value of x that satisfies this equation is 1.72, and this becomes the answer, which is the solution to the equation. If you compare this answer to the answer we got from the approximation technique, you discover that they are both exactly the same. Thank you for watching.